Good morning, everyone. I am Achal Gupta. I'm a graduate student at University of Illinois Urbana-Champaign. And today I would like to invite you all to this event. It's India-US Space Cooperation and Opportunities in Space Sector, sponsored by Indian Student Hub. So today we have with us Mr. Krunal Joshi, who is from Indian Space Research Organization, that's ISRO, and Mr. Alok Chatterjee, who is from NASA JPL, that's Jet Propulsion Laboratory. They're going to discuss about Indian space program and Indo-US cooperation. This would be followed up by a Q&A session. And I would like to inform you all that this meeting is being recorded and it is also live on YouTube. Also, if you have any questions for our speakers, please feel free to drop them on the chat. Siddhi, I'll pass it on to you.
Hello everyone, my name is Siddhi and I'm an aerospace bioastronautics graduate student from the University of Colorado Boulder. And our first speaker today is Mr. Krunal Joshi. He has been an ISRO counselor and has also been appointed as the Technical Liaison Officer at ISRO. And he has also contributed towards the joint Indian-American NISAR satellite project aimed at combating climate change, and it's scheduled to launch from India towards the end of the year 2022 or the beginning of the year 2023. So, Mr. Joshi, on to you.
Thanks, India Student Hub for this opportunity. So, namaskar to all of you. Good morning, good afternoon, based on your time zone. I'm going to just take you through the Indian space program. I'm not going to much on the details, but I'll try to give you a overall picture how the Indian space program started, what context it was, and now where are we today, and in our own way what we have achieved. And in between I'll try to cover the wherever possible India and US space cooperation. Fellow speaker Mr. Alok Chatterjee will cover on maybe a small detail, but more details will be provided by him. So we all know that 4th October 1957, we consider as a launch of Sputnik as a dawn of the space age, and then that the space race started and everything. Not very far, in 1963, India also launched its first rocket, though it was a sounding rocket from the Indian soil. So what it signifies that along with that national vision, we had that science and technology vision at early days. And the Dr. Vikram Sarabhai, Dr. Homi Bhabha, all played a very key role to establish the space program. And during those days of zero infrastructure, will see in a future slide how we worked. Now today, we have a very self-reliant space infrastructure wherein we have our own independent access to the space. So it was always questioned that space technology for the country like India, a developing country like India, how much it is suitable, is it a waste of money or not? But India has converted that discussion to our advantage, wherein we have taken the space technology for the development of the nation. So how it started, that you know that Thumba Tulls in a small church, we started launching, it was a kind of a program office, and from there we started launching the sounding rockets. And that was those days of fishing element. Our Alok ji has worked there, I think, in that area. Also my fellow speakers. So those were the early starting days, and we were doing these sounding rockets experiments, and especially those experiments were for the upper atmosphere testing and observations and all those things. And that time there was no ISRO, there was no ISRO or the Department of Space. That was a COSPAR, Committee on Space Research. And with the international collaboration, US Apache rockets were also used initially for the sounding rocket experiment. So that's where how the initial international collaboration came into the picture, and we started working. And that's how the Tumba Equatorial Launch Site, TULS, started. And we started taking those baby steps towards the Indian space program. Before we move in, we just try to understand what was the India's approach for this entire space program. If you see the most of the leading spacefaring nations today, we are seeing they were having a very stable ICBM platforms, and they use those platforms to convert it to launch vehicles, and those launch vehicles then they use for the launching the satellites, and then applications followed by that. While India took the reverse approach, we had our first applications were developed earlier. And then based on those applications, we started developing the satellites. And then parallelly for the launching of those satellites, we started developing the launch vehicles. So that was a unique approach, application driven approach India opted for. And it is still, we consider, and in fact, not we, world also acknowledge that India is a leader in the application program in the space. And it is all started because of the vision of Dr. Vikram Sarabhai. So it's a very long vision statement, but the words which were very profound during the entire journey of the Indian space program is that we must be second to none in the application of advanced technologies to the real problems of the man and society. And this was the driving principle, driving force for the Indian space program. And today's entire space program is a vision of the Dr. Vikram Sarabhai. So how it all started, we were doing all those small sounding rocket experiments, and we were trying to build small subsystems and other things. But as I told you, we wanted to have a good experiment or the applications which can help the common man. Those were the days when the NASA USA was developing the ATS-6 advanced technology satellite, and Vikram Sarabhai came here and said we will lease this satellite for our activities. And those were the 1967, and we said okay, we will have a lease agreement with the NASA for the one satellite. Satellite was built and launched, and after a 72-73 period, and it was moved on the Indian region. And then the program started called Satellite Instructional Television Experiment SITE, which is considered as the largest mass communication experiment ever carried out in the world. 2,400 villages, which were most of them were not electrified. Electricity was not available, and so our target was to take that electricity, develop the programs for the agriculture, education, trainings, family planning, and use that satellite for this purpose. And this is how the entire project got started. It started on July 1st, 1975 with American satellite. And then it paved the way. It showed to the world that what can be done with the space technologies. And it also paved the way in the Indian decision makers, that also they understood the power of the space technology, where it can help. And that's how it paved the way for the Indian satellite system, INSAT. And we have a STAP and SITE programs that also helped in this project. And this were the kind of initial blocks which paved the INSAT satellite INSAT system. And these are the early days. I'm sure you would have seen these photographs. Somebody carrying the nose cone of these rockets on the cycle. And this is that famous photograph that Apple, the first Indian communication satellite, was actually not. It was not transported. It was getting tested for some EMI testing on this bullock cart. So with this kind of resources, things have been started. So it also matters how you started and where we are today. So from those modus, what you call the very limited infrastructure today, ISRO is spread across the India. We have 13 major ISRO centers developing a rocket fuel to the rockets and satellite payloads and satellite applications, everything. And along with that, we have a research institutes, some 6 or 7 research institute, 2 public sector units. So all across the India, now we have presence with what we started with a very modest kind of thing. And what we have what we have accomplished in this period is a 191 missions total we have completed. Out of that, 78 launch vehicle missions, 111 satellite mission, where includes the 12 student satellites, and then 5 famous that experimental missions, reusable launch vehicle, and then space recovery, space capsule recovery experiment, and crew module. And apart from that, we have 342 satellites for more than 33 countries were launched on board our PSLV. And then host of the space technology applications were developed. So I will go slowly in detail, all slides, everything. So this talks about the current space assets, what kind of numbers we are having, and please keep in mind these numbers are very dynamic. While we are talking, one satellite may have some issues and other things, and so we have a very good space assets, having a 17 communication satellites, around 2022 remote sensing and the meteorological satellites, our own navigation satellites, 8 navigation satellites, and 3 space science missions are there. So I'll start with the communication things. As we discussed that Apple was the first communication geo satellite we launched, and Apple itself was a kind of a experimental satellite on the Ariane vehicle. It's a Ariane passenger payload experiment. So when Ariane 4 was getting tested and nobody was ready to fly, we said, okay, we'll have our own satellite, and it was a kind of a free ride. We got it, and we make use of that. From there, we have Inset 1 series where we procured the satellites with our specification and foreign collaborations. We made our own satellites in Inset 2 series, then Inset 3 series where it was a kind of a combination of a communication satellite and meteorological satellite. And this boom structure was very famous, Indian satellite kind of a, become very famous. From there, we had two commercial satellite, two fully grown commercial satellites for HILAS 1 and WTM. We built for the UK and the France. So this is how we grew in our communication satellite activities. Once upon a time, we leased the satellite from the NASA ATS-6 for our communication experiment to a place where we have now our own high throughput satellites. And with the help of these all satellites, today in India more than 65 million active DTH customers are there. Host of VSAT services are being utilized for the stock exchange, with the banking sector, hospitals. We have our own EduSat network and telemedicine network, and we are augmenting our fleet with our high throughput satellites and the satellites in the different band, Q band, V band, all those things. And the MSS satellite, mobile satellite services also coming into the picture. So these all critical services currently we are providing with the help of Indian communication satellites. So this is how we have grown in these communication activities. So along with the communication, as I told you, initially we use them for that meteorological purpose also. And slowly we had our own dedicated meteorological payloads. Kalpana 1 was the first dedicated meteorological satellite. And after that, we have a 3D and 3DR, so which are giving you weather forecasting services 24/7 over the Indian region. And initially, we had those models and other things. We had from the Canada, we got it. But then slowly we started developing our own models and our own data sets to use for our own applications, because India has a very variety of terrain which has a different requirement, and we started developing our own models based on that. Coming to the remote sensing satellites, as I told you, always our approach was application driven. So how we started, we started remote sensing application with detecting the coconut root wilt disease study in Kerala, and it was a helicopter based survey, not a space based. And then that's how that remote sensing started happening. And slowly we started realizing that okay, it can play a big role. In fact, India was the one who realized that importance of that remote sensing, space remote sensing, and how it can be utilized for the other day-to-day applications for the farmers, fishermen, and other activities. And we started building applications, and accordingly we started building the satellites. All started with the Bhaskara 1 satellite, and then we started building the IRS series, then ocean set for the ocean state monitoring and other things, and resource set for the monitoring of the resources, various mining resource and other things, and the cartoset series for our cartographic applications. And then it came the RISAT, which paved the way for the radar satellites, all weather remote sensing. So this is again that what kind of a, like if you want to identify the crop, you need a better spatial resolution. Then we made it a IRS series. When you want to detecting and quantifying these moisture, stress, and other things, then we started SWIR satellites. We started better radiometric resolutions. We made a resource set series. Then you need a high resolution for the various cartographic application. We made a cartoset series. So all these applications, and then for that application, we developed the technology. What kind of technology? The instrument development, and then for that instruments, we accommodate in the satellites. This is how that application started. And what has happened today, we are having one of the world's largest fleet of Earth observation satellite for the civilian use. More than 22 satellites are in orbit, and they are oceanography, resource monitoring, weather disaster cartography, energy, all those areas we are having applications for that. So these are the some of the applications I would try to cover, from the monitoring of the glaciers and snow. Obviously, agriculture, we want to know the crop production, area estimations, other things, groundwater prospect, weather, climate, weather, and sorry, one more slide I will take it on the weather and disaster management. And that potential fishing zone. This is a very much talked about application of the Indian science, wherein we give a guidance to the fisherman with the help of our incoys. Small center is there, that these are the areas where you can find a big catch, and which doesn't also that it also takes care of the mating season and other things, reproduction. So it also ensures that ecosystems are balanced, and at the same time, with the lesser search time, the lesser fuel, get a good catch. And it has become a very popular application among the fishermen. So along with this, for the disaster management, we extensively use the space infrastructures for the cyclone, floods, forest fire detections, and landslide. And we have a multi-tier database for those things. We have a kind of a single window delivery, which delivers to the IMD and other people what data they need. And it played a big role during the Kedarnath floods, Kashmir floods. And I'll just give you this example. This is the service or the application developed with the help of the INSET 3D and 3DR. These are the geo-based weather satellites. It gives you the track of the cyclone, real-time prediction of the cyclone track, and the fall time and other things. And this is just a cyclone track of the Hudhud cyclone which was there. So what has helped out of this? If you see in the 1970, we had a cyclone Bhola, and human casualties were around 5 lakh, because you don't know where it will land, what time it will land, what speed it will come, and you can't have a prior information. And obviously it will be very difficult for the administration to manage, the giving the population size and other things. And in the recent, we have a cyclone filing. So see the kind of the lives we have saved. So we always say this is the saving the human lives from this kind of impact space program can have it. And on this continuation of this remote sensing satellite, we have a very good joint collaboration with NASA and ISRO, where we are making a NASA-ISRO synthetic aperture radar, NISR. It's a joint development of the both the agency, wherein the NASA will bring the L-band radar and ISRO will have a S-band radar. ISRO has already delivered the S-band SAR here to JPL for the further integration. It will get fully integrated and characterized. It will be sent back to the India, and it will be launched somewhere in a 2022 and 2023. And apart from that, we also had two very good airborne remote sensing mission, which is known as AVRIS NG, wherein that NASA instrument is flying on Indian aircraft, and in ISR, wherein an Indian instrument is flying on a NASA aircraft, and in the different sites of the India and US, we are covering for the various observations. So coming from the remote sensing, we'll go to now the navigation side. We know the GPS. Everybody talks about GPS. There is something called GLONASS from the Russia. India also felt that we should have our own navigation system, NAVIC. So it's like a navigation with the Indian constellation. So our intention was only to focus on the Indian region, Indian subcontinent. So we have made our own regional navigation system with the help of a 3 geo satellite and 4 geosat satellite, uh, which gives you around a 10-meter accuracy, which is sufficient for our application. It covers around 1500 kilometers from the Indian territory. So now it is fully operational constellation and started that. Now chips are also getting developed for that, and very soon we will see in our mobiles also NAVIC also. So that this is also a good achievement for the country like India, wherein our own uh, totally indigenous developed solution for the positioning and navigation is there. Apart from that, we also have our Gagan payload, which is nothing but it authenticates the GPS signals and retransmits. This is very useful for the civilian aircrafts when they are moving from one region to other region. They should have a seamless connectivity. So they use the GPS for that period. And so for that also we have a good payloads, and 3 payloads we have developed for the Gagan applications also. Coming to the most exciting period, and I think we all get excited with this space science and astronomy field. So there, up to 2008, we were very focused on the application portion and doing things for the thing for the country and application. But then we started learning that okay, now we have enough capabilities to think about going beyond Earth, and it was started with the 2008 Chandrayaan-1 mission, wherein that was again a very international cooperation, very successful international cooperation example, wherein 11 payloads were there from across the globe, and NASA also had 2 payloads on that. Apart from that, Germany, Bulgaria, Sweden also contributed for the payload, and M-Cube and Minisar, which was a very famous payloads from the NASA, were there on the Chandrayaan-1, and Mr. Alok will cover more about that. After that, we had a successful Mars orbiter mission. We had an astronomy mission. Then again Chandrayaan-2, wherein that orbiter is still functioning, and there also we had a LRA from the NASA on Chandrayaan-2 lander. Unfortunately, it could not reach to the, could not complete the soft landing. So all this space science, astronomy, we started giving that angle to our own entire space program, that wherein we started working on the how we can use the expertise developed over the year for this kind of scientific knowledge base. And to launch all those kind of variety of satellites, as we discussed, we parallelly always develop the launch vehicles, starting from sounding rockets, and we had a famous SLV-3 where Dr. Abdul Kalam led the way. After that, we have PSLV, and 50 consecutive successful flight, one of the most reliable launcher in its class in the world currently. And as I told, more than 300 satellites from the 33 country and 200 satellites from U.S.A. in last 5 years we have launched on board the PSLV. And then recently we got that GSLV, it's got now operational, and GSLV Mark III. So the capacity of launching satellites into geo orbit has touched almost around 4,000 kg. So it's a very good achievement. A country like India, wherein we started from the scratch. We did not have something kind of ICBM kind of things which can be utilized for the rockets. We have used our sounding rocket activities to take into the cryogenic activities, and now we have our own self-reliant access to space, and we always want to reduce the cost to the access to space to reduce that. So during this entire thing, what has happened, what transpired, though we along with this entire flamboyant activities of the space activity, we started building the capacity for the country. In our own way, we have our wind tunnel facilities, our launch pads. We started making crew escape systems and space systems, all small technology over the years we have developed. So the space program grew. Along with that, the country's capacity also got increased in variety of field. We have our own lithium-ion battery system now that we can develop. We have thermovac chambers which can help. We have MOTR, multi-object tracking radar systems, plasma wind tunnel facility, variety of facilities we established for the country. You may be surprised that we are having a country's only 180 nanometer fab. And today's time, when you are talking about 7 nanometer and 14 nanometer, 180 nanometer looks very big number. But it is to be understood here that if you know the basics, you can always scale it up. So currently, that we have a very good CMOS fab in Chandigarh. We are operating. So all these things got developed in the journey. And all this data, we have talked about so many data with the help of the remote sensing satellite, meteorological satellites are available on these platforms. Bhuvan, Vedas, Mosdek, you can access this platform. And host of applications now people are making. Students, academia is coming forward and they are using this data. Vedas is the one platform where I would like you people to visit, wherein number of applications have been developed, and we have developed a wind renewable energy sources like wind and solar. What kind of energy it can produce in next 7 days, 10 days, and this has been given to the now so many users, not in only India, in South Africa and other continents also. So this kind of capacity also was built for the country. And my one of the slides I told more around 12 satellites we have built with the help of this university. So it gives you kind of a hands-on experience for the students to make the satellites on the one of the test flights and other things. We have 6 technology cells, space technology cells in IITs, and around 900 response projects across the academia we are running. So it has not only created the direct employment like us in space for a country, but apart from that, there are structures for the indirect employment also have been corrected. More than 350 technology we transferred, and maybe artificial polyurethane food and the distress alert transmitter are one of the very well talked about TTs which have been utilized for the country. ISRO has a very good international cooperation, 230 agreements with 55 countries and 5 multinational bodies. We work with all major spacefaring nations. We have very good relations with all spacefaring nations. And these are some of the more detail about the space cooperation with the USA. I'll just highlight 2 things about that. In education sector, we have a Professor Satish Dhawan Endowment Fellowship with the Caltech, when the students from the IST complete their masters and other things. And we also have a passive wherein a professional exchange program with the NASA and ISRO, where both the side we exchange our professionals and they stay, they visit these centers, they exchange ideas and other things. Apart from there are many other activities which we have carried out. We also have a Asia Pacific training center for the all countries which are in Asia Pacific region, for the giving them ideas about the remote sensing and the space technology. Maybe aware about that India also built the South Asian satellite for our neighbors. We gave a satellite, a communication satellite to our neighbors, Afghanistan, Nepal, Sri Lanka, Bangladesh, Burma. So they are also taking our services, and we are making a satellite and for the Bhutan also. And this is the much talked about recent times Gaganyaan program. So as you all know, now ISRO has geared up themselves for the Gaganyaan program, the first human space flight program we are planning in around 2023 period. Before that, we will have a 2 unmanned flights, and if COVID permits, we know, because now the schedules are driven by the COVID things and other things. So we are now started doing host of the activities, because the space flight for the humans are the different ball game. So we're mandating the launch vehicles, developing the environmental systems and other things, ECLSS and other things. All those activities are started, and we hope that 2023-24 will achieve that first manned mission. So Indian space program rode ahead in a very short way. We said, okay, we would like to reduce the cost of access to the space. SpaceX has taken a lead really, and they have really significantly they have reduced the cost. But we are also working on that aspect. We would like to have a high power throughput satellites for the communication requirement, high resolution hyperspectral for our remote sensing requirement. Also would like to have a Chandrayaan 2 and Chandrayaan 3 kind of missions to be continued. Gaganyaan we already talked about, and we also would like to focus on the application portion. That is the driving force, and would like to have these all capabilities shared with our international partners. So we believe that space has no boundaries, and we should have that in our working pattern also. So I'll end my presentation with this famous cartoon. So with all constraints, we started our journeys. Okay, so when constraints are more, then you love to perform more. So this was the famous cartoon NYT published on the successful Mars mission on first attempt, and this was then answered by one of the Indian newspaper when we had 104 satellites launched on PSLV. So that was on a lighter part, but yes, on our own way, we have achieved a sizable things. Our budgets are constrained, other resources are constrained, but our efforts and the spirit for the country is not. And with all available resources, I feel that Indian space program has achieved something. So thank you very much. This is the Bahubali, what we call it, the GSLV Mark III. That I'll say. Thank you very much.
Thank you, Mr. Krunal Joshi. We had some really exciting bits in that presentation to take away from. Welcoming our next guest speaker, Mr. Alok Chatterjee, who has been a project engineer at Jet Propulsion Laboratory at NASA for over 36 years. And he is an Indian American engineer managing the mission interface aspect for the NISAR satellite project. He is also a senior engineer, has been at ISRO for more than 9 years now, and has worked on India's rocket design under Dr. Abdul Kalam. Mr. Chatterjee has completed his BTech honors in aeronautical engineering from IIT Kharagpur, and followed by his MS in aerospace engineering from Iowa State University. So, Mr. Chatterjee, on to you.
Okay, great. Great to see you all. And, we just heard a very impressive ISRO achievements in space sector in India. I started off my professional journey by working for ISRO since I was actually an intern at VSSC Trivandrum ISRO, in Tumba, in my my fourth year. At that time, engineering degrees were took 5 years, so I was there for the fourth year internship. I met at that time ISRO was really going through its foundations, early foundation, because ISRO was, I think, legally formed or organizationally formed in 1969, if I'm not mistaken. And I had a front row seat in seeing how ISRO was developing at that time, a very nascent state. And it was a privilege to work with Dr. Kalam as my mentor, along with Dr. Brahma Prakash and Gavarikar and all of those people. So it was something a young engineer would give anything for. So I had that front row seat, and some of the pictures that Krunal shared were very nostalgic. I still remember that church where it all started. A few times I visited it. and the beautiful beach that was adjacent to it from where rockets were launched. Every Wednesday, actually, at 8 p.m., there will be a launch, and they will allow outside visitors also to come and witness it. And so it was quite an impressive beginning to my rocket career, so to speak. And then, of course, I was involved with India's launch vehicles design. At that time, SLV-3 was the talk of the town. Dr. Kalam was the project director, and the first one failed, but the second one succeeded. And I still remember the celebrations that took place, with all the employees at VSSC, and it was quite an achievement. It was, I think, a 40-kilogram satellite that was launched with SLV-3 and put into a low Earth orbit. That was quite an achievement, graduating from sounding rockets. So and then I, of course, worked on future rockets design, particularly PSLV and the beginning of GSLV. At that time, India was thinking about building its own cryogenic engine, but that didn't happen for a while. I left ISRO in '82 to pursue my higher studies in the U.S. After working 9 years at ISRO. And at that time, ISRO was a very ascending trajectory in terms of capacity building, as Krunal pointed out. And I think today it has come to a stage where it's at par with all the world agencies in terms of capabilities and skills and whatnot. So I think it's a big space program. As you saw the map of India, it spread all over the country, and I believe there are now increased impetus on developing private sector in India related to space. I think the new government is trying to build that capacity because in the U.S., other than NASA, there are a lot of big aerospace companies, and they are actually self-sufficient on their own. They just carry out the requirements from NASA and Department of Defense for space assets, but they are quite big companies. And I think India is thinking about in those times. Currently, the vendors in India are small, and they only supply subsystems to ISRO. But I think in the future, we're going to see new entities coming up and building up their own capacity and compete in the world in terms of private space sector business. And I also know that quite a few new startups have started coming up in India related to space. So you might want to look into that and see what opportunities are out there. So anyway, that was the introduction. Okay, so this chart, I have only one slide, basically talks about two major collaborations in the recent times. As I said, India's space program started off by launching the NASA-provided Nike Apache sounding rocket in 1963. Actually, it was Krunal who mentioned that. And so that was a beginning of the Indian space activities. But over a period of time, I feel that relationship didn't flourish or develop, I think because of the political alignments of the two nations. There were bits and starts here and there, some support work, but no major collaboration where both parties are equally involved developed since that time till we came to 2005 onwards, where I came to know that Prime Minister Vajpayee had announced a moon mission called Chandrayaan-1, and then Dr. Kalam announced, at that time he was the president, he announced that there will be an announcement of opportunity for foreign payloads on it. And so I took that challenge and proposed to my management at NASA JPL that why don't we take part in this collaboration with India through this AO. We quickly put together a proposal and sent it off to Dr. Kalam. then that proposal was forwarded to ISRO headquarters, and ISRO, at the time, Dr. Annadurai was the project director of Chandrayaan-1, and it was sent to him and the science committee that was in evaluating the science of merits of the proposal. And that's how M3 from JPL was selected as one of the payloads out of the 11. And then the collaboration started happening beginning 2005 when we got funded by NASA to fly on the Chandrayaan-1 mission with the M3 instrument. This instrument, it was very small because the mission had only a very limited capability for foreign payloads. This was only 8 kilograms and a very small but very powerful instrument. It was state-of-the-art hyperspectral imaging spectrometer with high resolution on both space and spectral resolution. And so we quickly developed this instrument to fly, and then I was resident in Bangalore for about 18 months, making sure that this instrument gets integrated with the satellite and gets launched. So that was quite an experience. It gave me a chance to renew my relationship with ISRO leadership. And then we also talked about future collaborations. Of course, this was a successful mission. It launched on October 22nd, 2008. And within 9 months, we were able to gather all the data, scientific data that was planned for on the moon. And it was even though the mission came to a premature end, but all the science objectives, I would say 95% of the science objectives are already achieved. And so you can see the result of the mission. So tracking and trajectory support to this mission through its DSN, Deep Space Network, that exists, and JPL manages that. And eventually this instrument led to the discovery of water molecules on a wider surface of the moon. And that was quite a very unique discovery at that time. And of course, it was substantiated by a few further missions and instruments that went to the moon. So definitely moon is a place that water does exist in some form or the other. I'm sure we all know that in the polar caps, the deposits are pretty substantial. Then, of course, this successful collaboration led to another big collaboration called NISAR that Krunal mentioned again. Since I had developed a good relationship with Dr. Annadurai at ISRO in Bangalore, I was able to propose to him or initiate a negotiation on developing this collaboration starting in June 2011. That was my first conversation with him. And over the months and years, we were able to come to an agreement as to what this mission would be. It's a very high, sophisticated dual frequency synthetic aperture radar, which will be flying for the first time in that configuration in space. But prior to that, as Krunal was pointing out, there were airborne missions with that, but this was the first time that a dual frequency space-based synthetic aperture radar was going to be launched. And as you can see, the configuration is pretty complicated. And it is, we develop a new technique of measuring all the changes that are happening on Earth as we speak, whether it's coastal, whether it's ice movements or land deformation, landslides, disaster management, and whatnot. I mean, comprehensively, this mission will be able to produce data which will operate, this mission will operate 24/7 because, it doesn't, radars don't have any problem penetrating the clouds from a high up orbit. And so it can measure all the time. Every 12 days, it will repeat the same spot because the way we selected the orbit, it will select the same spot and see what changes have happened on that spot. And so that way we can see if there was an earthquake or, if there was a land deformation, the accuracy is in terms of centimeters. And so that's a very powerful instrument. And we are currently at a stage where we are assembling all these parts at JPL, including the ISRO provided payload, which is the S-band SAR. And we are providing the L-band SAR, and they're being integrated as a complete payload. And once that is done, it will go back to India and will be integrated with the satellite in Bangalore. And then they'll be transported to Sriharikota for launch sometime early 2023. And believe it or not, the data that will come down from this mission is unbelievable. It's like 20 terabits per day. Unbelievable amount of it, which has never happened in space in the world. And you can imagine there'll be hundreds and hundreds of PhDs that could be produced from analyzing that data. So universities in India and abroad and graduate students and students could get involved and analyze the data and produce, get their PhDs and produce papers, scientific papers in world journals. So keep an eye on that, work with this, try to get connected with this mission in India. I know that a lot of universities are now getting involved in India in the data analysis. I think similar thing happened with MOM data, the Mars mission data, but I was told that there were not enough scientists or students who were able to use that data to analyze and produce data products. So again, I mean, this shows that if you are interested in this kind of activity, which is very scientific and application oriented, here's an opportunity for you to get involved in this mission through ISRO, and I'm sure ISRO will encourage that. So with that, can you show the video clip I have for the NISAR mission? It's an animation, it's less than 2 minutes, and it just gives you an idea of how this is all coming together and where we are. So that was a quick overview of the mission itself. It's just from launch to insertion into the orbit. But after that, it will be working for at least 5 years, gathering the data, all related to changes on Earth in a very comprehensive manner. And hopefully, it'll really enlighten the world about what our own planet behaves and undergoing changes. So in that sense, it's a very important mission. And I'm glad that both India and ISRO and NASA are working together on this. It's a dream come true after initiating it in 2011, and hopefully we'll see it launch into early 2023. So that's my short interaction with you on that. Thank you.
Thank you so much, Mr. Alok Chatterjee. That was great to learn, and also the animation was very insightful. So, handing over to Anshul to conclude the ceremony.
Actually, we do have some questions from the students. And since we have a time with Mr. Chatterjee, I would like to ask those questions first to him. Mr. Chatterjee, one of the students asked, having worked at both ISRO and JPL, what challenges does you faced while joining NASA? And did you face any security clearance since you were an Indian citizen?
Well, yeah, I came here as a graduate student, and then after I completed my master, applying for jobs, and for me, and it's so different for me because at the time I got married to a green card holder here, and so we were able to get our green cards before I could apply for jobs. So it really never posed any problem for me. But in any case, I was, even if I was not married, I would have applied and seen and whether this is a possibility or not. So eventually I got offers from Boeing and JPL. And of course, for obvious reasons, I chose JPL because it was more close to my heart. And that's how I started. So I really didn't go through a whole conversion from F1 to J1 to H1B and to green card and all of that process. So I know some people at JPL who have gone through that process. Recently, I talked to somebody who was a graduate in mechanical engineering from Delhi University, and she also interned in I think NRSC Hyderabad, which is another ISRO center, and also PRL, Physical Research Lab in Ahmedabad. And then she was also a volunteer at the Nehru Planetarium in Delhi. And then she got very interested in planetary science. So she applied abroad and she got accepted by University of Arizona as a graduate student. And she completed, while she was completing her PhD, she had a chance to work with scientists, professors at Arizona State University, who were doing work for NASA, analyzing the data and doing research. So she was able to work on the Cassini data, and then another time she was able to work on synthetic aperture radar data from previous missions. And that's how she developed her expertise and became good at what she was doing. And she was accepted as a postdoc at JPL after that. And then eventually her performance was very critical and very solid, that JPL offered her a position and then sponsored her for the green card. So that path is also there for students. But you have to be outstandingly good, and you have to be interns at good places, so where you can really learn something, and then of course perform well in colleges, so which you are graduating from. So all of those things matter. The offers are very limited and restricted, so you have to really try your best to be able to do that. So having internship in NASA centers is a good idea, and I think foreign students, if they are in the U.S. universities, can apply for that. Maybe not for jobs, because they probably need a green card or citizenship. Then, of course, I became part of JPL in 1985, and then I got my citizenship, and then I also got my security clearance because I was working on the Titan rocket that was launching Cassini. So I had to get clearance for that. So eventually, over a period of years, I was able to get to a state where I could really be involved in a lot of the work that's going on, NASA and JPL.
Thank you. So we have another question from a student here. Considering the Indian and US markets, what would be the opportunities for international students in the aerospace sector in both US and India?
Well, I can definitely answer the US part. Space is a strong business in this country, as you know. There are a lot of, not only NASA is just one of them. There are a lot of big companies who are doing this kind of work. And so there are opportunities over there. But again, the kind of work they do is national security and national importance. So there will be some restrictions. But the best way I said I was of getting involved is through internship, through your PhD program, through your postdoc program, and do well in wherever you are while doing all of that. So there's a chance that you might find your way into the market here. Other than that, I'm not an expert on how to find jobs in this area, but that's what I think would be the right path for people to follow. And of course, there are private companies and like SpaceX and Bezos and Blue Origin. Those kind of companies are coming up, and you can definitely apply and first try to get in as an intern and do well and get accepted, and then within the US labor laws, if they think that they can sponsor you, they will do it, because they do need critical skills.
Just to put things in a perspective, space industry is a more than $300 billion industry. So let us understand that it is not a small kind of a things which you see on the launching a few satellites or rockets or something. It's a very depth. It is a very depth variety of what you call domains are part of the space. As they say that all engineering or all branches of studies culminates in a space. So it's a very huge. Just a small correction, maybe what Dr. Alok told in that Indian students may find difficult to get the internship in a NASA because of that I2C agreement, which is not signed between India and ISRO and NASA. But apart from the NASA, there are host of private industries here, which are doing a fantastic job. They're doing really a great job, including the SpaceX, which will encourage this kind of internship programs and other things. What Dr. Alok told, Mr. Alok told, it is very right. Internships are the right path. You build your understanding, and you first of all you get clarify that what you are actually opting for is here you are interested or there or not. Because watching a launch is very exciting, but doing activities and doing all small things, it takes a lot of effort.
In my case, of course, doing the graduate studies, but my experience at ISRO for 9 years also was a work in my favor when I was applying for jobs.
That's so true, Mr. Joshi and Mr. Chatterjee. One last question for both of you. So what do you think about space tourism? Because that's the main thing going on right now in US. Do you support it, or do you think there are any problems which NASA need to solve or like restrict this industry? This is directed towards both of you.
Yeah, so I would think that space tourism is a good thing. It gets, it creates public interest in space, as well as it's good for the economy. But again, the technology has to be very reliable, as you know, for any human space. So these companies are not naive when they do these kind of things. They have researched the market. They have found that the people would be interested to fly into space, however short. But I think they feel that the technology is robust and reliable enough to at least conduct the space tourism part of it. Maybe not at this point go to planets or any far from the Earth, but it'll be around Earth and 1 or 2 orbits around Earth and then come back. It's definitely in the realm of possibility technologically, and I'm sure these experts know that these are also economically viable too. So if you want me to answer that question, I definitely support the space tourism venture that's happening now. Whether NASA will go along with that or not, I don't think so, because NASA's charter is different. NASA's charter is to do very challenging and unique based on technology development, and it just gets involved in that kind of research. I don't think there will be the arbitrators or deciders of whether private companies should do space tourism or not. It's their call, and if people support them, why not?
Yes, I also feel it is inevitable. It is going to be there, and this kind of as things attracts the public attention, and then it helps to give the awareness about the space activities. I also feel this will also pave the way for the future colonizations of other planets and other things, because slowly we'll build those technologies. So I also feel that is a very much there. It will be there, and nothing wrong about that.
Uh, So true, sir. I would like to thank Mr. Alok Chatterjee for joining us today. We would continue with Mr. Joshi, but since we are in a time limit with Mr. Chatterjee, I would really like to thank you for joining us today and giving us a really good presentation and giving us an idea on how to proceed with our professional careers. Thank you so
Yes,
much.
it was a pleasure. Thank you so much. Namaste.
Namaste.
So
Thank you, Krunal, for arranging
Thanks,
this.
Alok. Thank you.
thank you, sir.
Appreciate you joining. Thank you.
So hello, Mr. Krunal Joshi. One of the questions for you would be for the Gaganyaan mission. Currently, what are the problems that ISRO is tackling, and are the Vyomanauts selected already?
Yes. So the second question I'll answer first. That Vyomanauts for the first mission, yes, they got selected, and they were been sent for the training and other things, and that part is already over for at least for the first mission, I can say. For the subsequent missions, yet to be finalized. Coming to the what kind of problems we are facing, we don't consider them as a problems. We consider them as a challenge. And obviously, if you don't do something new, you will never face any challenge. So you understand that this is launching the satellite is a one thing, and launching a human being is a different ballgame. We need to do a mandating of the launch vehicles, mandating of the, as that's what I was trying to say, that the uh, chambers in which the crew in which it will they will be a house for the 3 to 4 days. Uh, all all the activities what we are doing in a normal course of day in here, they all that astronauts have to do, the womenauts have to do in that small capsule for 4 to 5 days. So obviously it is all challenge, and we are working towards that. The mandating of the launch vehicle is the one most important things, because that is the first stage, and then bringing back them, sending is easy, bringing them back is very difficult. So bringing them back is a more challenge. So those are the activities we are focusing on right now.
So true, sir. So there are other questions from students, and most of them are about being an Vyomonaut. So currently, speaking from my personal side, from the childhood, I do wanted to become an astronaut, and it would be an honor to be an astronaut for India. But my question is, what background does it require? Because currently, I know it's like only the Air Force members, or sorry, Air Force people are selected for being a Vyomonaut. So is there any possibility in future for civilians or like the PhD scientists to become an astronaut or become a Vyomonaut in a way?
Yes, I'll say yes. In future, there is obviously a possibility. This being the first mission, and it is a starting. If you see the today NASA's that battery of astronauts what they are having, most of them comes from the Air Force or the Navy pilots and other things, because they are the ones who takes the lead in terms of the maneuvering and other things, and the physical requirements and all those things. But at the same time, then they will be having a payload experiments, and other experiments will come, and then for that payload scientist will come, for the pharma scientist. So slowly, as the programs gets maturity, other fields also will come in the future. So yes, and long term, obviously, but in a near future, we'll have this path.
Yes, sir. Thank you so much. For the next question is, what are the emerging fields in space technology, and what skill sets should students have uh, to get an opportunity in this technology field?
Okay, emerging fields, I'll say one we talked about space tourism. Now everybody is talking about the space tourism, but that is actually an output. The field, if you see, there are many other activities goes for that. Reusable launch vehicles, reusable capsules. Uh, there is a talk about the space-based the solar powers. All activities are going on in those areas also. So variety of now it is a space is ubiquitous, and a variety of application can be developed out of that. But I feel that what kind of skill set you need is the basic. If you are a good engineer, mechanical engineer, a good basic with the fundamentals you can you can contribute. If you are a good electronics engineer, you can contribute. If you are a good metallurgy engineer, you know what kind of materials to be developed. So I taught in before also I talked. Space is the field where all branches get culminates. So what we need is the basic fundamentals that which helps us to solve these problems of space, and all those other things you will not learn in colleges or the university. Once you will get into the institutes, you will start learning. The basic skill set is a attitude to to be ready to learn new things.
Thank you, sir. Next question would be about the from a student. How can indigenous manufacturing and RD be given a boost such that India can be propelled faster in aerospace domain? Same as you mentioned about NAV-IC in your presentation.
uh, Indigenous R&D and the productionization, obviously it's a big subject. You need a when you say R&D, we are doing a very good R&D, and our respond program. I'm talking in terms of the ISRO context and in terms of the Indian context. The respond program is involved. We are involving many academias to come and do a job with us. Space technology cells are there, wherein they can build a small satellite with us. That's how we can do the R&D. But when productionization comes, it calls for the volumes and other things. So there we need to have a more private players coming into the picture. And you may be aware that current government has declared the space reforms in 2020, wherein private players are encouraged to be a partner in the space program. So I'm sure this will pave the way for the productionization and other things.
Thank you, sir. The next question is, for private space sector in India, how is ISRO planning on supporting the startups in the aerospace field in India?
So again, as I told, the space reforms 2020, they have paved the way. The body called In Space has been formed, which will encourage the private partnerships, startups to play a role in a space program. We are also planning to facilitate the utilization of the ISRO facilities for these startups and other things. So now policy has been given to us. Now that other guiding principles and operationalization, other things are being under pipeline.
Thank you, sir. Next question is from Ms. Bharti Bhisht, and she is saying that I worked on NASA UCLA program on bone degeneration on long space flight. She want to return to India and do microgravity and stem cell based experiments. Any suggestions how to align, how to, sorry, align with any Indian program?
Okay, so microgravity and other things will become now very important when it human spaceflight program and other will take up. So you can always, you are most welcome to join the Indian space program. How to join ISRO? I'll say there are three methods which I personally know. One is the ICRB, what is called ISRO Centralized Recruitment Board. You join as a scientist engineer C, and then you grow in the rank and file. There is a program for the campus recruitment for the Indian IITs, Indian Institute of Technologies, few IITs, wherein we directly recruit from them the IITs. And the third way is for the, especially I don't know about the Ms. Bharti's background, if she's doctorate. We have also a program where directly lateral entries, we give it to the PhD students who have completed PhDs, they want to join at some higher level. For that, you can visit the ISRO websites, and there are some emails and the box are given wherein PhDs can directly apply. And based on the requirement, we call them for the things. But the best way to join the ISRO is for the youngster is to ICRB, the ISRO Centralized Recruitment Board, which conducts every year exams. We take electronics, mechanical, and computer science and related branches, and then we train them with us.
Thank
Of
you.
course, IIST is the one way. You can always go through IIST.
Thank you, sir. And the last question, the Indian spacesuits contract, are they being designed indigenously, or is some international firm owing the contract for building the spacesuits for?
Okay, tricky questions. Obviously, we will do everything on our own at least once. Okay, we have already developed our spacesuits based on. I think I showed some photographs in my presentations also. So we have done the basic research and other things. But when it comes to the decision of who will make and where it will be made, obviously it will be kind of a global tenders and other things, and we encourage a global participation for that also. So it may happen that yeah, we know the basic technology, we have done it, but we may also decide based on the make or buy decision of the management where it will be manufactured.
Thank you so much, Mr. Joshi. It was really insightful and interesting to hear from you about ISRO missions and answering all those questions. Thank you so much. And I would like to uh, end this event by thanking both of our speakers, since Mr. Chatterjee is not here, but still I would like to thank both of them for giving their valuable time and answering all our questions, maybe as silly as they may be. And I would like to remind all the students and participants that this event was recorded and it would be available on Student Hub website. That's ishubus.com, ishubus.com. You can also see it in the Zoom chat. And if any one of you or any students who want to contact Mr. Joshi or Mr. Chatterjee, feel free to email Student Hub, and their email address is indiastudenthub@gmail.com. Thank you so much, everyone, for joining here, and I wish you all the best. Thank you so
Thank
much,
you very
sir.
much, Anchal and Siddhi. And I can only say, whatever modest resources you have, but if you have commitment and grit, you can achieve something. So in Indian Space Research Organization, ISRO is a classic example. It is one of the most successful department of the Indian government with all given resources. The current budget of the NASA this year budget is a $23.1 billion, and the Indian budget is ISRO's budget is a $1.91 billion. So it's not the resources which decides what you will do, but yeah, the greed and the commitment. So I invite all of you be a part of an Indian space program. It will be a very tough journey, I know, but obviously you will have a satisfaction of achievements. Thank you very much for hearing us out. Thank you very much.
Thank you so much, sir.